All right, we're on 7.04, which we're continuing on with our trig stuff. So we're going to talk about something really important today, and that is the unit circle. So the unit circle has a center at 0, 0, and a radius of 1. It always has a radius of 1. When we talk about the x-coordinates on the unit circle, we're actually talking about cosine of theta, and the y-coordinate is represented by sine theta. And that is really, really important that you need to know that. So as an ordered pair, instead of x comma y, it's going to be cosine theta, sine theta. Very important to memorize. Also, we know that tan theta, which is our opposite over adjacent, TOA, which is normally y over x then, would be sine theta over cosine theta. And we'll talk about that a little bit today, but we are going to talk about it more in the future. But it's something really important that I want you guys to start memorizing and start recognizing. All right, so we're going to take a few minutes to talk about this unit circle. So here's the circle. Here's your origin right here where the center is. And a lot of the things on the unit circle are going to repeat. So we're not going to talk about all of them, but we're mainly going to focus on this first quadrant and then the 4 places at the end of the axes right here, at the end of the x-axis and the end of the y-axis. All right, so first let's talk about the axes. So here we have 0 degrees or 360 degrees. And we also need to know what each of these are in terms of radians. So we talked about last class that pi radians is equal to 180 degrees. So now 180 degrees is over here, which means that is the same as having pi radians. So 180 degrees pi radians is if you go from here all the way to here. If I'm trying to find this point on the unit circle, remember the radius of the unit circle is 1. So if I want to get to this point over here, if my radius of the circle, which is half the length of your diameter, is 1, I'm going to the left 1 and then not up or down at all because I'm staying on that x-axis. So that would be the point -1, 0. So what that means is, since the ordered pair is cosine comma sine, think x comes before y in the alphabet, c comes before s in the alphabet. X before y, c before s. So that tells me that the cosine of 180 degrees is -1, and the sine of 180 degrees is 0. That's what this ordered pair tells me right here. So let's jump back over to this one. So 360 degrees. So if I know that pi is 180, I know that 180 times 2 gives me 360. So in radians, 360 degrees is 2 pi. To find this point on my unit circle, I'm going right 1, because again, the radius is 1, and up nothing. So that would be the point 1, 0. So again, what that means is the cosine of 2 pi is 1, and the sine of 2 pi is 0, or the cosine of 360 degrees is 1, the sine of 360 is 0. So again, this is the cosine of 360 degrees, and this is the sine of 360 degrees. And that's what all of these ordered pairs are going to tell us, the cosine and the sine. Okay, let's finish our axes. So now here we're at 90 degrees. And again, we wanted that in terms of radians. So of course you can use the proportion we talked about last class to convert. But with 90, I know that's half of 180 degrees. So if I know 180 degrees is pi, and 180 divided by 2 gives me 90, then pi divided by 2 is going to be what my radians is for 90 degrees. And this point, I didn't go left or right at all, so that's 0. I went up 1 unit because the radius is 1, so that point would be 0, 1. So the cosine of 90 is 0, the sine of 90 is 1. And then we'll do this bottom one here. This one is 270 degrees, and in radians, that's going to be 3 pi over 2. And I know last time we converted that using the proportion, which you're welcome to do to verify that. And then the ordered pair, we didn't go left or right any, and we went down 1 this time, so 0, -1. So those are the 4 axes and what you guys need to memorize for each of them. So you need to know the degrees, the radians, and the ordered pair for these 4 points that we just talked about in pink. All right, now let's talk about your first quadrant. So for the first quadrant, we have we're only going to talk about our special angles here. So these are the ones that came from those triangles we talked about last class. So 30 degrees, actually 2 classes ago that was, I think. So 30 degrees is the first one. So again, you can use your proportion to convert, or you can say to yourself, I know 180 divided by 6 gives me 30. So in radians, this would be pi over 6. To get these ordered pairs, now I do want these memorized, but I'm going to show you real quick how you can get them as well. So outside of this triangle, I'm going to draw a 30, 60, 90 triangle. And we should have this memorized. So across from the 30 is 1, across from the 90 is 2, and the 60 is rad 3. So if I want the cosine, because I know cosine comes first, of 30 degrees, that's adjacent over hypotenuse. So adjacent is rad 3, hypotenuse is 2. So this one's going to be rad 3 over 2. And then I want the sine of 30. So sine, again, that's so toa. The sine is opposite over hypotenuse. So opposite my 30 degrees is 1 and the hypotenuse is 2. So that's going to be 1/2. All right, next, let's talk about 40. Actually, you know what? We're going to jump over to 60 degrees here. So this one's going to be our 60 because that one uses the same triangle. So I'm going to jump to that. I'll do that in blue. So 60 degrees is going to be pi divided by 3. 180 divided by 3 gives me 60. For that one, if I look at this 60-degree angle right here, I want the cosine first. Cosine always comes first. C comes before S in the alphabet. Is adjacent over hypotenuse, so that's 1/2. So it's just switched here. And then the sine is opposite over hypotenuse, so opposite the 60 degrees is rad 3/2. So you'll see these 2 points are the same values, just switched. The sine and the cosine are switched. The last one in quadrant 1 is 45 degrees. I'll do that in black. And that's pi divided by 4. And that one, we're going to use a 45, 45, 90 triangle since it has a 45-degree angle in it. Label that. Again, that should be memorized as 1, 1, radical 2. And again, we want cosine to come first. So cosine is adjacent over hypotenuse. So it doesn't matter which 45-degree angle we look at. So adjacent is 1, hypotenuse is 2. Was rad 2 rather, but I can't leave a radical in the denominator, so I need to rationalize that. So to rationalize it, I multiply the top and the bottom by rad 2, leaving me with rad 2 over rad 2 times rad 2 gives me 2. So this would be rad 2/2. And then the sine is opposite over hypotenuse, which is opposite would be 1/rad 2. So it's the same thing, 1/rad 2 rationalizes to rad 2/2. Okay, so what I have right here on my paper is what I want you to have memorized. So these pink ones on the axes, degrees, radians, and the ordered pair. So you need to memorize the degrees, number of degrees, the number of radians, and the ordered pair. And memorize them for the 4 quadrants. They're the 4 axes, let's say, and the first quadrant. So these pink, I'm saying, are the 4 axes and this first quadrant. Okay, so now just to kind of show you how it applies to the rest of the unit circle, I'm going to make this whole line purple right here for the 30-degree angle. So that makes a 30-degree angle right here. So every line that has a reference angle of 30 degrees, so over here would be purple, over here would have a 30-degree reference angle, meaning, remember, a reference angle is the angle that's formed with the x-axis, positive and acute, so there would be 30, and here would be 30. All of these purple lines are going to have the exact same cosine and sine. So the only thing that will change is the sign, so being positive or negative. So like over here, it's still going to be rad 3 over 2 and 1 over 2, except since it's in the second quadrant, I'm going to go left. So I'm on the negative x-axis, so it'd be negative rad 3 over 2, and then I'm going up, so that would be positive 1 over 2. Okay, and then down here would be negative rad 3 over 2, negative 1/2. And then here would be positive rad 3 over 2 because we're going to the right, and then negative 1/2 because you're going down. Now, all of these ones that make a 45-degree angle with your x-axis, so all the middle lines right here I'm putting in black, those are all going to have the same cosine and sine as well, but again, just the signs will change. So this is also going to be your rad 2 over 2 and rad 2 over 2, except the first one, the cosine, will be negative because you're going left first, then up. Here it's going to be negative rad 2, negative rad 2. And here would be positive rad 2 over 2, negative rad 2 over 2. So really important that you understand that these are repeating in each quadrant. And then same thing with this 60-degree angle right here. So any that have a reference angle of 60 degrees, so all these blue ones, those will all have this as their cosine and sine. The only difference will be whether they're positive or negative. So this one would be negative 1/2 because you're going left, and then positive rad 3 over 2. All right, so, and then degrees and radians is obviously going to change in all of those as well. But right now, I really want you guys focused on these 4 axes and this first quadrant. The other thing I'll tell you is a couple little tricks that I have to memorize these. I try to remember that the 3 and 6s go together because a lot of times students want to say that 30 degrees is pi over 3. But 30 degrees, think about if you took a pie and divided it and you made 30-degree angles, slices, then you would have 6 slices there, versus if you made them with 60 degrees each, you would have 3 slices. So think the bigger angle, if you only have 3 slices, that's going to be bigger slices of pie. So 3s and 6s go together here. And then the 4s go together, 45 degrees and 4. Then with these, looking at your ordered pairs here, notice they all have a 2 in the denominator. Every single one, all 6, have a 2 in the denominator. Then if you look at just the x coordinates, as you go up, it's rad 3, rad 2, rad 1, which is just 1. Here, it's rad 1, which is just 1, rad 2, rad 3. So if you can remember 3, 2, 1, 1, 2, 3, and they all have a 2 on the bottom, that can help you to memorize them. And then these are usually a little easier for students to figure out here in memorizing those. Remember that pi is 180, and sometimes that will help you to figure out the rest if you can do that in your head. And then also these ordered pairs, remember the radius is 1. Okay, so now let's go talk to at the bottom here. It says using the unit circle, determine each of the following values. So the sine of 30. So all I want you to do on these is go to 30 degrees and find which one is the sine. So we know sine comes second in the ordered pair. So cosine of 30 is rad 3 over 2. The sine of 30 would be 1/2. So remember that sine is your y coordinate. So that's going to be 1/2. Cosine of 90. So cosine is the x coordinate. So what's the x coordinate of 90 degrees? The x coordinate here is 0. All right, pause the video and do the rest of those on your own. All right, so cosine of 180 was your x, so that should have been -1. Cosine of 45, also your x, and that one is rad 2 over 2 for the x coordinate. Sine of 90, sine is your y, that would be 1, and sine of 0 is your y again, and that would also be 0. All right, moving right along here. Now let's talk about your coterminal angles. So for coterminal angles, we talked about these last class. Coterminal angles are angles, think co, together, terminal, they terminate or they end. So these start and end together. All right, so find two coterminal angles, one positive, one negative for each of the following. So last time we did this, we did it in degrees. This time we're doing it in radians. And for this year, we tend to try to, it's like learning a new language. You think in English if your native language is English. And so when you learn a new language like Spanish, you're probably thinking about it in English and translating each thing in your head. But if your teacher in Spanish asks you a question in Spanish, you're expected to give a response in Spanish. Same thing here. If I give you a question in radians, like this one, I'm expecting you to give me the answer in radians. Now, at this point for this year, we're going to be working mostly in degrees, except for these ones, it's a little easier to stay in radians to do them. So I'm going to show you how to do these completely in radians. But a lot of the other stuff, which we'll talk about in a couple minutes, we might need to convert between degrees and radians to make it a little easier for ourselves. All right, so last class we did degrees, and then to get to another coterminal angle, you just take the angle, add 360 or subtract 360. Now we know that 360 degrees is equal to 2 pi radians. So instead of adding and subtracting 360, you're going to take the angle, the measure of the angle, and add or subtract 2 pi. And that way you don't have to convert because it's a very long. If you convert this to degrees, add your 360, subtract your 360, and then convert them back, both back to radians. It just takes a lot longer. All right, so let's see how we can do this. So we're going to take 13 pi over 4. Let's start by adding our 2 pi. So if you were doing this in your calculator, you're going to type in 13 over 4 plus 2. Don't type in the pi's because then it won't change it back to a rational number. So just type in 13 over 4 plus 2 and change it to a fraction. If you're doing it without, which is good practice because we, in our last unit, just talked about how to add fractions, we need a common denominator. So I would multiply this by 4 over 4. And that gives me 13 pi over 4 plus 8 pi over 4, which gives me 21 pi over 4. So that's another coterminal angle, an angle that would start and stop in the same place as 13 pi over 4. Now we need a negative one, so let's subtract 2 pi. So again, we're going to get a common denominator by multiplying by 4 over 4. If you're doing it in your calculator, you should be typing in just 13 over 4 minus 2. Do not type in the pi's, and then just hit math frac if it gives it to you as a decimal. All right, so this is 13 pi over 4 minus 8 pi over 4. And 13 minus 8 gives us 5 pi over 4. So still a coterminal angle, but not negative. And we were asked to find a positive and a negative. So now we need to subtract another 2 pi from that. So I'm going to take 5 pi over 4 now and subtract 2 pi. Now I've clearly seen that 2 pi over 4, or 2 pi over 1 with a denominator of 4 is actually 8 pi over 4. So I'm just going to use 8 pi over 4 at the start here. And 5 minus 8 will give me negative 3 pi over 4. So that's a negative coterminal angle. If I wanted another negative one, I would take negative 3 pi over 4 and subtract 2 pi from that. If I wanted another positive coterminal angle, I would take 21 pi over 4 and add 2 pi to that. Okay, so now pause the video. I want you to find a positive and negative coterminal angle for negative 2 pi over 3. So same thing, please make sure you start with the angle. So write down the angle first, then add your 2 pi, then subtract your 2 pi. All right, so again, you should have added your 2 pi, gotten your common denominator. Check that in your calculator. And a positive angle would be 4 pi over 3. A negative coterminal angle would be negative 8 pi over 3 if you subtract 2 pi. And again, in your calculator, you would type in -2/3 plus 2. Change that to a fraction if it doesn't give you one. So that should have given you 4/3 in your calculator. And then you would just bring along the pi as if it was like an x of a variable. All right. Next, moving right along, talking about reference angles again. So with radians and reference angles, if your angle has a 3, a 4, or a 6 in the denominator, then the reference angle will be, and this got cut off, will be pi over 3, pi over 4, and pi over 6, respectively, which just means in that same order. So if it has a 3 in the denominator, then the reference angle is going to be pi over 3. If there's a 4 in the denominator, it's pi over 4. And if there's a 6 in the denominator, it's pi over 6. So a little bit different this time, not the 3s and 6s don't go together this time. So a lot to keep track in your head with all this stuff. All right, so here, pretty quick for these first three, we've got -2 pi over 3. Well, there's a 3 in the denominator, which means that my reference angle is pi over 3. Next one, I've got 7 pi over 4. There's a 4 in the denominator, so my reference angle is pi over 4. And number 5 has a 6 in the denominator, so my reference angle is pi over 6. Now number 6. It does not have a 3, a 4, or a 6 in the denominator. So this one is a lot more work. So we go from really easy to quite a bit longer. So for this one, it's not one of our special right angles, not a 30 degree, 60 degree, or 45 degree angle. So I need to first, I want to convert this to degrees. So change to degrees. So here it's going to be easier for me to work in degrees. So I'm going to change it to degrees, find my reference angle, and then change it back to radians, which is why this one is so much work. Next year in pre-calc, you'll talk about more how to do this kind of thing without converting between degrees and radians. So more thinking in radians all the time. All right, so to convert this, it should be pretty quick. There's a pi in it, so we're just going to sub in 180 in for the pi. So that's going to give me -11 times 180 divided by 9. You can put that right into your calculator. It should give you -220 degrees. So that's step 1. Now that I have it as in degrees, I want to find the reference angle. So this is what we talked about last class. So you're going to sketch -220 degrees. So if it's negative, that means we're going to start by going down first. So this is -90, -180, -270. So we're between -180 and -270 at -220, going in that direction. To find your reference angle, remember you want to squiggle your terminal side and the side of the x-axis that's closest to it. So this squiggled purple angle, that's my reference angle. That's what I'm looking to find right here. So to find that, I know this angle from here to here is 220 degrees in the negative direction. And from here to here is 180 degrees. So how do I find the purple angle? Well, I can take 220 and subtract 180, and that would leave me with just that purple piece right there. So 40 degrees. So that's my reference angle in degrees. Now I need to change the reference angle back to radians. So we're going to use our proportion to do that. So our proportion we need to memorize is pi over 180 equals radians over degrees. So my degrees here is 40. And you could call that x or r, it doesn't matter. Now we're going to cross multiply. So 40 times pi equals 180 times r. Divide both sides by 180 to solve for r. And then you're going to put 40 over 180 in your calculator, or 4 over 18, and reduce that. And you get 2/9. And don't forget to bring your pi along. Again, in your calculator, do not type in 40 pi over 180, just 40 divided by 180. And our final answer then is 2 pi over 9. So a lot of work to get to that point right there. Okay, so we've talked about our unit circle, finding the cosine and sine off of your unit circle. We talked about coterminal angles in radians as opposed to degrees that we talked about before. Talked about reference angles in radians, which we've already talked about in degrees. And now we're going to talk about where these trig functions are positive or negative. So a lot of different things that we're covering in today's lesson. If an angle is in, this is for this last part. If an angle is given in radians, the answer must also be given in radians. So that's really important that I was saying that for number 6, because I gave you that angle in radians, your answer must also be in radians. All right, so here we have where our trig function's positive or negative. So again, you want to remember that the cosine of theta, that's your x coordinate, and the sine of theta is your y coordinate. So as an ordered pair, it's going to be cosine theta, sine theta, or x comma y. This right here, all students take calculus. Sorry if you hear the drilling. All students take calculus. This is going to tell us where each one is positive. Just a little trick to remember it. So here's how we usually do it. So we say A stands for all, S stands for sine and its reciprocal, cosecant, T stands for tangent and its reciprocal, cotangent, and then C stands for cosine and its reciprocal of secant. All students take calculus. That tells us where they're positive. I'm going to give you another way to remember this as well. So here, if we get in quadrant 1, we go over, which is positive to the right, and we go up, which is positive. So cosine's positive, sine's positive. Tangent, remember, is sine over cosine. So if I divided sine over cosine, positive divided by positive is a positive, which tells us everything is positive here. In quadrant 2, you're going left, which is negative, and then up, which is positive. So that's why here cosine is negative because that comes first, sine is positive. Tangent, which is sine over cosine, positive divided by a negative would be negative. So the only one that's positive is sine here. Tangent in quadrant 3, you're going left, which is negative, and then down, which is negative. So both cosine and sine are negative, but if you divide sine divided by cosine, negative divided by a negative, you'd get a positive. And lastly, here you're going over to the right, which is positive, and then down, which is negative. So cosine is positive, sine is negative, tangent, which is sine divided by cosine, negative divided by a positive is a negative. So the only one that's positive is cosine. So either way, whatever makes more sense to you. I will say most students tend to use the all students take calc, or you can come up with something on your own if you'd like, but we'll use all students take calc to remember this, and that tells us where it's positive. All positive here, here sine is positive, here tangent's positive, and here we're cosine positive. If it's not one of those things, then everything else is negative in that quadrant. So we're going to use that on these next few problems. So I'll write it out a few more times. All right, number 7 through 9. We're trying to find out where the angle terminates. So steps. Number 1, you want to find the possible quadrants. And number 2, you're just finding where they overlap or what they have in common. All right, so we're going to draw out our all students take calc. And I do want to see work for these as to how you're figuring it out and what's going on in your head. So the first one says secant is less than 0. In what quadrant does the angle terminate? So first of all, whenever I'm given secant, cosecant, or cotangent, I want to think about what is their reciprocal trig function. So secant, C's and S's go together, is the same as cosine. So these two will have the same signs no matter where they are. So secant is less than 0, which means it is negative. So that means cosine theta must be negative. So when I find out what quadrant that could be in, first I find out where is cosine positive. So cosine is positive in quadrants 1, where they're all positive, and it's positive in quadrant 4 with the C. C stands for cosine. I want it negative though, so those are the two that I don't want it to be in, because that's where cosine is positive. So if cosine is positive in these two, that means it must be negative in the other two. So it must be negative in quadrants 2 and quadrants 3. So this is 1, 2, 3, 4. So it's always positive in 2, negative in 2. So if you're asked where it's negative, first find where it's positive, cross those off. The other two are where it must be negative. Let's try another one, number 8. Again, I want you to draw out your ASTC, or all students take calc, right in order of your quadrants, 1, 2, 3, 4. So if cotangent theta is greater than 0 and sine is equal to 4/5, in what quadrant does the angle terminate? So first, let's talk about cotangent. Cotangent is the reciprocal of tangent. This says it's greater than 0, which means it is positive. So we want tangent to be positive, and sine is equal to positive 4/5, which means we want sine theta to also be positive. So now let's go over to our quadrants. Tangent is positive in 1, so I'm going to make those circles. So quadrant 1, and so they're all positive in 1, and also in the T right here in quadrant 3. So tangent is positive in quadrant 1 and 3. Now I'm going to go to sine. I want sine to be positive because that's equal to positive 4/5. So I'm going to do boxes or rectangles around those. So sine is positive in 1 because they're all positive in quadrant 1. And then sine is also positive in the S. And that means sine is positive, everything else is negative. So that's positive in quadrant 1 and 2. So now we're trying to see, where do they overlap? What do they have in common? Where are these both true? Because in order for the angle to terminate, both of those have to be true. And here you can see is where we have the pink and the purple, a circle and a rectangle. So our answer would be quadrant 1. So just like a little puzzle, trying to figure out where everything is true. All right, let's try number 9. Cosine theta equals 12/13. So cosine theta is positive 12/13, so that's positive. And sine theta is less than 0, so that means it must be negative. We'll write out our ASTC. Pause the video here, see if you can find where cosine is positive. Maybe do circles around that one. And then find where sine is negative and do rectangles around that one and see where they overlap. Also, good idea to write it out right here so you can see where, like underneath, so you can see what they have in common there too to show your work. All right, so give yourself a minute, pause it now, and then check back with me. All right, so cosine theta is positive, so that's going to be in 1 where they're all positive, and where C stands for cosine is positive. So we know it's positive in these two, so it's negative in the other two. So I only want to look at quadrants 1 and 4 for that. Now let's talk about sine theta. Sine theta is negative. So I know sine is positive first in 1 and 2. So if it's positive in 1 and 2, then it must be negative in 3 and 4. So again, these tell you where it's positive. So if you're looking for where it's negative, find first where it's positive, and it can't be those two, so it has to be the other two. So you'll see here that these overlap in quadrant 4. You can see on the picture, and you can see here where we wrote it. So our answer, our angle, will terminate in quadrant 4. All right, next, evaluate, round to 4 decimal places if necessary. So here we have the secant of 7 pi over 3. Okay, so grab your calculator if you don't have it right there. we want to evaluate to 4 decimal places. So again, we've already talked about how to do this in degrees. If you're finding the secant of 7 pi over 3, secant, C's and S's go together, is the reciprocal of cosine. Now here, where it's written as a fraction, the angle, it's very tempting for students to flip that. You're never going to flip the angle. You're going to flip the entire thing. So this is the same thing as saying 1 over the cosine of 7 pi over 3. Now, we tend to keep our calculators in degree mode. So I'm going to change this to degrees as I do it. So 7 times 180 over 3. So 7 times 180 over 3. In your calculator, we're going to do cosine, or actually we're going to do alpha y equals, and then I'm going to do 1 over cosine, and then I'm going to do alpha y equals again inside of there. Do 7 times 180 over 3. And then hit enter. So again, I'm in degree mode right now, and I get 2 for my final answer. If you did have your calculator, if you want to leave it in radian mode, I'll show you that real quick. You can also do it that way. So turn it to radians, and then you would just type in 1 over cosine of 7 pi over 3. So we would just do alpha y equals again and do 7 pi over 3. And that also gives you 2. So the top one is in degree mode. The second one is in radian mode. Again, though, we tend to keep our calculators in degree mode. So it's a little bit easier to just pop the 180 right in for your pi when you do that. Okay, pause the video and try letter B, which is the cosecant of 3 pi over 4. All right, so for that one, cosecant is the reciprocal of sine. We don't have a cosecant button, which is why we need to do this. So now we do 1 over sine of 3 times 180 over 4. So remember to convert 3 pi over 4 to degrees. We know pi radians is equal to 180 degrees. And then I'm going to do alpha y equals, type in 1 over sine of alpha y equals 3 times 180 over 4. And then we would write out that decimal. So 1.41423562, and round to 4 decimal places. So 1.4142 for that one. All right, and actually I'm going to stop here for these notes. I'm not going to do the Pythagorean identity part, so I know we've done a lot already today. So there's a lot going on. Again, really, really important to memorize that unit circle right here. You need to know each of the 4 quadrants, and then also, or each of the 4 axes, and then your first quadrant. You also need to memorize that cosine theta sine theta is an ordered pair, and tan theta is equal to sine over cosine for that. And then be able to find coterminal angles and reference angles in radians, and then also be able to determine where things are positive and where they are negative based off of the trig function. All right, so that is it. If you have any questions at all, I know it's a lot and it's all new for you guys. So really study it, because the more you know the unit circle, the easier it's going to make for the rest of the problems that we do. Especially also making sure you know your 2 special right triangles that we've talked about, the 45, 45, 90 and the 30, 60, 90. That will also make your life a lot easier if you have those memorized. All right, and that is it. I hope you guys have a great day, and pi out.